Welcome to today's video. Let's explore how a parallel plate capacitor works and its importance in electronics. We'll break it down in a simple way. A parallel plate capacitor consists of two parallel conductive plates separated by an insulating material called the dielectric. These plates can store electrical energy when connected to a power source. When a battery is connected, one plate becomes positively charged while the other becomes negatively charged. The positive terminal of the battery connects to one plate and the negative terminal to the other. These charges create an electric field between the plates. The amount of charge each plate can store depends on the surface area of the plates, the distance between them, and the dielectric material used. Electric field lines run from the positively charged plate to the negatively charged one. The stronger the electric field, the more energy the capacitor can store. Now, if you decrease the distance between the plates, the capacitance increases, meaning the capacitor can store more charge. This is because the electric field strength increases with a smaller gap. The dielectric material also plays a key role. Different materials have different abilities to store charge, known as their dielectric constant. A higher dielectric constant allows for more charge storage. The capacitance of a parallel plate capacitor is given by this formula: C equals epsilon naught times A divided by D. Here, epsilon naught is the permittivity of free space, A is the area of the plates, and D is the distance between them. When a capacitor is charged, it stores electrical energy in the electric field between the plates. This energy can be released when the capacitor is connected to a circuit. Capacitors like these are used in many applications, from smoothing out voltage fluctuations in power supplies to storing energy for short bursts in devices like cameras. So, to recap, a parallel plate capacitor stores energy by creating an electric field between two charged plates. The amount of charge it can hold depends on the size of the plates, the distance between them, and the dielectric material inside. Hope you found this explanation helpful. Don't forget to like, subscribe, and hit the bell icon for more physics and electronics tutorials. See you in the next video.